If you're going to graph a linear inequality, it is the exact same starting process as graphing any other line. So let's start by doing the things we usually do when we are graphing a line. Kyle Clark, if I was going to graph this as just a regular old line, nothing special, where would I begin?
By making an x and y table.
Well, I have my x and y axis. I mean, where on the graph am I going to make my first point, looking at this equation or inequality? -2 where?
On the bottom
The bottom of what?
of the graph.
What part of the graph?
The negative y.
Negative y axis. Okay, so we're going to start at -2 on the y-axis. Please make your first dot there like we usually do. We would then use the slope. And just like before, the slope is the coefficient in front of x, y equals mx plus b. I need to know what the slope is, though. Sarah Dinsey, what is the slope? It would be 1, and I like that you said over 1 because we want to rise over run. If you have a whole number, please put it over 1. Please follow along with this part as we go. We're going to make a bunch of points, but we are not going to connect them yet. So the slope is 1 over 1, so I'm going to go up 1, right 1 because it's positive, up 1, right 1. Make as many points as you can possibly fit on the x and y axis that you have drawn, because you're going to need the entire graph or the entire grid to do what needs to be done. Now that we've made all of our points, the question becomes, how am I going to connect them? And to answer this question, we have to think back to the beginning of September when we first saw inequalities, and we said we have these 4 different possible symbols: greater than, less than, greater than or equal to, less than or equal to. And back then we were graphing on a number line. Now raise your hand if you remember this. When we were graphing on a number line, sometimes we had an empty or open circle, sometimes we had a solid dot. How many of you remember this? We'd have a number line, there'd be a number, and we'd either make an empty circle or a solid dot at that number. How many of you remember doing this? Okay? Can someone remind us when it was empty and when it was solid? What did we look for that told us something about these symbols told us that we were going to either leave it empty or fill it in? Brittany? Perfect. When they were when they were underlined, we filled it in. When they were not underlined, we left them alone. We normally call these strictly greater than and strictly less than, and then greater than or equal to, less than or equal to. So when it was strictly greater than, it was an empty circle. When it was greater than or equal to, we filled it in. But we don't have dots on a number line now. We have points on a line. So the question then becomes, if these are supposed to be empty and this is supposed to be filled in, what would that look like as a line? I want to make a line here. What 2 types of lines would I use to show that something's empty or show that something is filled in? It's the same concept, but it would look different. Any ideas on what type of line I can draw that would represent something being empty or not actually there? Nikki? A dashed line, or some people call it a dotted line. So go ahead and write dotted / dashed. I don't care if you want to call it dotted or you want to call it dashed, but a dotted or dashed line. That's what we use to represent that it's not actually there, even though we're looking at it. And then for the other one, dotted or dashed, the other would be, any guesses? Starts with an S, ends with olid. Solid. Good. Okay, so solid line. So we either have a dotted or dashed line or we have a solid line. So let's go back to this example. Here's the symbol we're using. Please say out loud, is this a dotted line or a solid line? This is a dotted line because it is not underlined. It just says greater than. It does not say greater than or equal to. Since it just says greater than, this is a dotted line. So when we go to connect our dots that we made, please make a dotted or dashed line to connect them. What this means, to kind of explain why we're doing this, any point on this line, any point at all that you choose, maybe the point we started with, 0, -2, any point on this line, if you plugged it into our inequality, it would not be true. If I plugged in this point here, the point we started with, 0, comma, -2, it would say that -2 is greater than -2. Is -2 bigger than itself? No. It is not a true statement. Any point you pick on this dotted line is not true. There's one more thing we're going to do, though.
Yay.
None of those points are true, but there are a lot of points that are true. They are solutions, and we need to show where they are. Go back to the symbol. Does this say greater than, or does this say less than? This is the symbol for greater than. When you think of things being greater, we have two halves of this. This line we drew split our graph into two pieces. Some people would say left and right, but I look at it more as above and below the line that we drew. You guys agree? This half is above the line I drew, this half is below the line I drew. Well, if I want to show everything greater than, should I show the things above or below? Greater than would make you think above. Here's how you show that. You're going to shade this in. I don't care how neatly or sloppily you do it, as long as it covers everything it needs to cover. Every single point on the graph above the line that I just drew is a solution to this inequality. So I'm going to shade every last little bit of it in.
Did you put arrows because it's all above?
This does go on forever. You would put arrowheads on the ends of your line, but we're not going to try to put random arrowheads on the edges of our shading.
Oh.
What this is representing, since we explained what a dotted line means, this means any point in here. Any point at all. I could pick a point way up here, way over here, down here, almost on the line. Any point in the shaded area, if I plug it in, it'll give me a true statement.
What about
0, 0 is right in the middle there. That would be 0 is greater than -2, and it is. I could plug in a point over here like -3, +3. It would tell me that +3 is greater than -5, and it is. Any point in the shaded area, plug it in, it will give you a true statement. Your final answer is this graph. It's not listing a bunch of points. It's not showing anything else. It's not plugging anything in. This graph, this visual representation, is the final answer.